You know what's better than a wired mobile charger?
A wireless mobile charger.
So, the question arises, what is wireless charging? Wireless charging is one of the several methods of charging batteries without the use of cable or device specific AC adapters.
A wireless charger is made of two parts, a charging pad and a metal plate. The charging pad holds the transmitter coil and the metal plate holds the receiver coil. It is on this metal plate that the mobile device is kept. Between these two transmitter and receiver coils, energy is transferred from the charging pad to charge the mobile device. For a long time, there has been a constant effort of technology to minimize the use of wires in day to day appliances. They are inconvenient and often really dangerous.
The wireless charger is a product of this step forward. It is based on the concept of electromagnetic induction and is becoming widely popular.
To understand the concept of wireless charging, we need to go back to history. Hans Ørsted noticed that when he turned on an electric current in a wire, a compass needle placed on another experiment changed its position.
A decade later, English scientist Michael Faraday discovered electromagnetism. He strongly believed that if an electric charge could produce a magnetic field, as stated by Ørsted, a magnetic field should be able to produce an electric charge. Consequently, when he brought a conducting coil in the vicinity of a moving magnet, a current was induced in the former. This phenomena was termed as electromagnetic induction.
Nikola Tesla later built the Tesla coil, which was the birth of the idea of energy transfer through EM waves. He used radio waves to light a bulb from a distance through the Tesla coil.
Previously, electromagnetic induction was used for wireless charging. As depicted in the figure, when we bring a conducting coil in the vicinity of current carrying coil, a current is induced in the former. A longer induced current can be produced in the second coil by constantly switching the direction of current in the first coil. For this principle to hold, the appliance had to be placed very close to the charger. As you can see from the diagram, if the coil is moved too far away from the first coil, charging stops.
Therefore, recently there has been a steady drift towards magnetic resonance coupling. The coils in this technique behave like magnetic resonators. When an alternating current of a particular resonant frequency is passed through this, it produces a magnetic field. When another coil tuned to the same resonant frequency is placed in the vicinity of the first coil, it gets coupled through magnetic resonance and produces an alternating current corresponding to that resonance frequency. Now, this current can be plugged into any appliance, such as a mobile phone, that needs to be charged even at larger distances. There are many advantages of the wireless charger over the wired charger, such as it is extremely convenient. That is, rather than having to connect a power cable, the mobile can be placed just on a charging plate. Also, a large number of devices can be charged at a particular time. Furthermore, the system is much more robust. Also, less circuitry makes it safer to handle, which also implies less power wastage in terms of copper loss.
There are certain limitations to the wireless charger due to added complexity. Also, it is pretty expensive as the coils needed to be made impeccably to reduce the losses. Also, it may be low efficient due to stray coupling.
Recently, Nikola Labs, named after Nikola Tesla, invented a phone case that can charge the cell phone through the radio waves emitted by the phone itself.
The scope of wireless charging isn't just restricted to mobile phones. With steady advancements that are being made in this particular field of technology, it is highly plausible that one day our homes look like this.